It's nice out. Hey boys, it's really nice out. You want to play tennis?
Sure. I'm just doing nothing.
I wonder who will hit the ground first. A ball dropped straight down or a ball thrown forward at the same height?
Well, it's obviously the one that's dropped down first. Look at this. No, it isn't. No, it's obviously the ball thrown horizontally. The horizontal component of the ball will help it get down faster.
Well, why don't we interview a few folks beforehand? If a ball is thrown horizontally versus if it is dropped off of a building, which one will land first?
The one dropped.
Thank you. Okay, if a ball is thrown horizontally off of a building versus if it is dropped straight down, which one would land first?
I'm thinking this one dropped will hit the ground first.
All right, thank you.
That's my opinion.
Thank you.
But now, the force is going to make it go faster, but how it's going to go that way and not hit the ground yet, right?
Motion can be found everywhere around us, whether that be in the form of Cole dropping his Bang energy drink or me hitting an immaculate forehand in tennis. However, the specific field in physics that addresses or investigates the properties of motion without regards to causal forces is known as kinematics.
Okay, so there are 4 fundamental equations which actually define the study of kinematics. Displayed here, velocity final is denoted as Vf, A is acceleration, Vi is the velocity initial, D is the displacement, and T is time. As this is a one-dimensional set of equations, deriving it into 2 dimensions actually yields the y-direction equations and the x-direction equations respectively. Please note though that these equations only work under specific conditions where air resistance or technically friction isn't factored in.
Now let's apply these to something more tangible.
Here we are on the 3rd story of a parking garage in Tempe. We estimate that our starting height is around 14 meters above the ground. Each tennis ball has a mass of roughly 0.06 kilograms, and the acceleration due to gravity on Earth is 9.81 meters second squared downward.
Okay, so right behind me is actually the landing zone for where we're going to be testing the balls. We will repeat the process for 3 trials. 1, 3, 2, 1.
As it was demonstrated in the previous clips, the balls we dropped landed on the ground at approximately the same time. Now let's look at exactly why this is mathematically.
One of the fundamental rules of kinematics is that velocity exists in different components. So even though the x component velocities are different in these 2 balls, we can still use the y component equation. With these givens being the same for both balls, we do some calculations and we arrive at the time of 1.69 seconds, which is the same for both balls.
Okay, so now we have actually conducted 3 trials where we've dropped the balls accordingly. Any discrepancies within the experiment are likely due to 2 possibilities. 1, there is an unintentional but minuscule applied force in the vertical direction, or there's the presence of air resistance or friction on the balls, more specifically.
Despite this discrepancy, this experiment still serves as an example of how kinematic equations can be applied to real life. See, I told you they will land at the same time.
Bro, what do you mean? You thought the horizontal one would land first.
Shut up.
Bro, I swear if Gillman doesn't give us extra credit on this assignment...
Oh,